Hello, this is MEI Further Maths Core Pure. We're in the Sequences and Series section and on the third video on the standard formulae for the sum to n terms of r squared and r cubed. Here is the standard formula for the sum to n terms of r squared. There are a number of ways of proving this result, and some of them are in integral and some of them will be in your textbook. In the next section, you'll be learning about mathematical induction, and you'll be able to prove this result using that method. For now, you just need to be able to use the formula, which will be given in the formula book. Here's that formula again: n times n plus 1 times 2n plus 1 all over 6. That's the sum from r equals 1 to n of r squared. Pause the video for a moment and use that formula to work out this sum. OK, in this sum n is 20, so I've got 20 times 21 times 41 all over 6, and that comes out to be 2,870. For the sum to n terms of r cubed, there's a rather neat way of showing that it's the square of the sum from r equals 1 to n of r. This GeoGebra applet shows it rather nicely, and it's worth taking the time to look at it. Since the sum from r equals 1 to n of r is n times n plus 1 all over 2, when we square that, we get n squared times n plus 1 squared all over 4. There are other ways of proving this. In particular, you can prove it by mathematical induction, and you'll be able to do that soon. For now, you just need to be able to use the formula, which again will be given you in the formula book. Here it is, just to remind you: n squared times n plus 1 squared over 4. That's the sum from r equals 1 to n of r cubed. Pause the video for a moment while you work out this sum. OK, that's 10 squared times 11 squared all over 4. 100 times 121 divided by 4. And that's 3,025. There are more notes on integral on the standard formulae for the sum to n terms of r squared and r cubed. That's the end of this short video. The next video in this series is on using the standard formulae to find combined sums.